Okay, welcome back to the May 2025 IB Chemistry walkthrough. This is for SL Paper 1B. This is the last video in the 1B SL for question number 3, the last one. There's only 3 subparts, so this should be pretty short. And so this one is starting off with this reaction of some solid sodium hydrogen carbonate with some hydrochloric acid. It's being investigated using the same mass of a solid, some constant volume, and different concentrations of acid. Rather than using the traditional gas syringe, this is going to be tracking it through the mass loss because there is the production of CO2 that is happening. So that's how that's being represented. Very common type of reaction. And so we have this graph. And so the first thing that is asking us is to determine by annotating the graph the initial rate of release of CO2 in grams seconds to the negative first with the 1.5 concentration of HCl. Okay, and so if we look, there's 2 things that we should note here. Is one, that for the 1.5 concentration, we are going to be looking at this lower line. Okay. The second thing is that this is the initial rate of release. Okay. This is not going to be an average rate of reaction. This is going to be an instantaneous rate of reaction. Okay. The other thing that we should note with this says by annotating the graph. Okay, so this should tell us that we're not just going to be doing change in concentration over change in time. We're not doing the average rate of reaction. Because we have to annotate the graph, that's a sign that we need to draw a tangent line. Okay, I realized after, I don't remember if it was the last video or I think it was the last video, is that when I do a ruler on my GoodNotes, it doesn't show up in the screencast. So you can just imagine my ruler here, I guess. But I'm going to be essentially trying to draw this tangent line to the, where's my little thing? To this spot right here. That's where I'm trying to do a little tangent line here too, okay? I'm going to draw it. So this is going to be roughly here. You can't see my ruler, but there's a ruler, okay? So there is my little tangent line. And so then I'm going to pick 2 points from the tangent line. I'm going to, just to make this easy, make this from up here. So that's going to be roughly like 9.1, but it is the y-intercept. And then this x-intercept, which is roughly around like I'm going to say like 2.5-ish to 4, because you may notice here the graph doesn't start at 0, it starts at 4. So it's not technically an x-intercept, actually. Anyways, there we go. Okay, cool. And so then we are going to just find the slope by just doing y2 minus y1 over x2 minus x1. I don't know why I have to wrap it every time I say it, but that's just how I learned it in like middle school. Okay, and so I like to always label these because I'm stupid. X1, y1, x2, y2. So our slope is just going to be 4 minus 1, not 1, 9.1. See, I even read that wrong. 9.1, okay, divided by our 2.5 minus 0, okay? It's going to be the absolute value because no matter what, you have to have a positive value for your rate of reaction because the rate of reaction cannot be negative, okay? And so 4 minus 9.1 divided by 2.5. So that gets us roughly 2.04 grams seconds to the negative first, okay? The official mark scheme gives 2.3 or something, but it doesn't give a range. And so this is where I'm genuinely unsure of how the IB marked this. On myself, I had taken this myself and gotten like 2.5, I think. And so like literally if you just like 2.5, like on the mark scheme, it's 2.2, which is an oddly specific number for this really small graph, like, you know? But if you literally change like 2.5 to 2.2, like that's 0.3 off in our estimations here. And it resulted in a like 0.5 difference or something. No, 0.2 difference, my bad, sorry. And so I don't know how, whatever. I'm going to assume that they were lenient on this because with the small differences in estimations resulting in pretty decent shifts in this slope. I'm going to assume that they had like a range that they used. I don't know why they didn't put that in the mark scheme, but anyways, I'm just going to assume as long as you annotate it and it looked like a tangent line, they assumed it was valid, like we did here. So we're going to go with that 2.04. 2.3 also works. Like I feel like anything from 2 to 2.5 would be valid. Anyways, this part 2 is going to be determining the average rate of release. So that part is going to be the change. Is my pen died. Okay, going back to this one question, my Apple Pencil died. Anyways, so determining the average rate of release, and so that means that is just going to be the change in concentration over the change in time. For the 0.5 moles decimeters cubed to negative third over the first 20 seconds. Okay, and so you are going to, since this is in grams second to negative first, you do not need, like, your change in concentration is more like your change in mass over your change in time. Okay, so we're just going to change that real quick just to make it more clear. So our change rather than concentration, it's going to be change in mass. If this were a different, since that's how we're defining our rate and our units, we don't have to convert it to concentration. If it did say moles decimeters cubed, we would need to go from grams of carbon dioxide to moles per decimeters cubed, but we don't even have that data. So anyways, we're going to go change in mass over change in time. This is for the first 20 seconds. So it's going to be 20 minus 0. And then this is for the concentration of 0.5. So now rather than looking at this bottom line, we're going to look at this top line. So for 20, we are here. And so that is roughly 2, 4, 6, 8, 8.2 grams. There we go, at there. And then for our initial, so it's like 9.4 grams. Okay, so our P average is going to be this 9.4 minus 8.2 divided by 20. Okay, so let's get our calculator. 9.4 minus 8.2 divided by 20. That gets us 0.06 grams seconds to negative first. So that's going to be the average rate of release of CO2 for those first 20 seconds for that lower concentration. Okay, and so that last question for this 1B, woo, we made it, is suggesting with a reason whether the sodium hydrogencarbonate or hydrochloric acid was the limiting reagent using 0.5 and 1 concentration. Okay, and so this is where you have to think about what graphs normally look like with the limiting reagent. Okay, and so if this was hydrochloric acid, was the if sodium hydrogen carbonate, God, I forgot the name for a second. Sodium hydrogen carbonate was the limiting reagent. All of these graphs, all of these would have the same plateau because regardless of our concentration of hydrochloric acid, it would be the sodium hydrogen carbonate that was in control. Okay, but because they have different plateaus for each concentration, that is showing us that the concentration of hydrochloric acid is determining the maximum yield, and therefore that is the limiting reagent. Okay, it's always the plateau that is showing you the limiting reagent, right? It's always that plateau. That's what it's showing you. Okay, and so limiting reagent is going to be hydrochloric acid, and so our reasoning is going to be because they produce different max yields of CO2 at different concentrations with the same mass of NaHCO3. Okay, so if it was NaHCO3, then they would have the same plateau no matter the concentration. And since they are different plateaus, different max yields, that means hydrochloric acid is the limiting reagent. So that is also, it should be noted with this question before we end this, is that this is a 1 mark question. So that means that you can't just guess. You have to guess and get the right reason. Both of them are required for the mark. It's always really important to look at that stuff. Okay, so that is concluding the paper 1B walkthrough for the SL. If you are HL, go and look at the videos in this playlist for the SL, the HL unique marks that we will then go over as well.